Welcome to the fascinating world of toxicology. In this video, we'll explore the basics of toxicology, the science that studies the adverse effects of chemicals on living organisms. Toxicology is all around us, from the medicines we take to the chemicals in our environment. Understanding toxicology helps us make safer choices and protect our health. Whether you're a student, a professional, or just curious, this journey will give you a solid foundation in the key concepts and principles of toxicology. Let's begin by understanding what toxicology is and why it matters in our daily lives. Toxicology is the scientific study of toxins and their effects on living organisms. It examines how chemicals, whether natural or man-made, can cause harm to humans, animals, and the environment. Toxicologists investigate the mechanisms by which substances produce adverse effects, the symptoms of exposure, and how to prevent or treat poisoning. This field is crucial for public health, environmental safety, and the development of new medicine. By understanding toxicology, we can better assess risks and make informed decisions about chemical use. History of toxicology dates back thousands of years. Ancient civilizations such as the Egyptians and Greeks documented the effects of poisons from plants and animals. Over time, toxicology evolved from folklore and trial and error to a rigorous scientific discipline. In the 16th century, Paracelsus, known as the father of toxicology, famously stated, "The dose makes the poison." This principle remains central to toxicology today. Understanding the history helps us appreciate how far the field has come and why it's so important in modern science. Toxicology is built on several key principles. The most fundamental is that any substance can be toxic if the dose is high enough. This means that even water or oxygen can be harmful in excessive amounts. Toxicologists also consider the route of exposure, how substance enters the body, and the duration and frequency of exposure. These principles help scientists predict and prevent harmful effects, ensuring safety in medicine, industry, and everyday life. Toxic agents come in many forms. They can be chemicals, biological substances, or physical agents. Chemical toxins include pesticides, drugs, and industrial chemicals. Biological toxins are produced by living organisms, such as bacteria, plants, or animals. Physical agents like radiation can also cause toxic effects. Recognizing the different types of toxic agents helps us understand the wide scope of toxicology and the various ways harm can occur. How a toxic substance enters the body is called the route of exposure. The main routes are ingestion, eating or drinking, inhalation, breathing, and dermal skin contact. Each route affects how quickly and severely a toxin acts. For example, inhaling a toxic gas can cause rapid effects, while skin contact might lead to slower absorption. Understanding exposure routes is essential for assessing risk and developing safety measures. One of the most important concepts in toxicology is the dose-response relationship. This principle states that the effect of a toxin depends on the amount or dose received. Low doses may have no effect, while higher doses can cause harm. Toxicologists use dose-response curves to determine safe exposure levels and identify thresholds for toxicity. This concept guides regulations and helps protect public health. Toxic effects can be classified as acute or chronic. Acute toxicity results from a single short-term exposure and often causes immediate symptoms. Chronic toxicity, on the other hand, develops over a longer period due to repeated or continuous exposure to lower doses. Both types are important in toxicology, as they help us understand the risks of different substances and how to manage them effectively. Toxicokinetics is the study of how a toxin moves through the body. It involves four main processes: absorption, distribution, metabolism, and excretion. These processes determine how much of a toxin reaches target organs and how long it stays in the body. Understanding toxicokinetics helps toxicologists predict the effects of exposure and design effective treatments for poisoning. Absorption is the process by which a toxin enters the body from the environment. This can happen through the skin, lungs, or digestive tract, depending on the route of exposure. Factors such as the chemicals, properties, the condition of the skin or lungs, and the presence of other substances can affect absorption rates. Understanding absorption is key to predicting how quickly and severely a toxin will act. Once absorbed, toxins are distributed throughout the body via the bloodstream. Some toxins accumulate in specific organs, such as the liver, kidneys, or fat tissue. The distribution depends on the chemicals, properties, and the body's physiology. Understanding where toxins go in the body helps toxicologists predict which organs are most at risk and how to treat exposures effectively. Metabolism is the process by which the body breaks down toxins, usually in the liver. Some chemicals are converted into less harmful substances, while others may become more toxic. The rate and pathway of metabolism vary between individuals and chemicals. Understanding metabolism is crucial for predicting the effects of toxins and developing antidotes or treatments. Excretion is the process of removing toxins from the body. The main routes are through urine, feces, breath, and sweat. The efficiency of excretion depends on the chemicals, properties, and the health of the excretory organs. Effective excretion reduces the risk of long-term toxicity and helps the body recover from exposure. Several factors influence how toxic a substance is. These include the dose, duration of exposure, route of entry, and the individual's age, genetics, and health status. Environmental factors such as temperature and presence of other chemicals can also play a role. Understanding these factors helps toxicologists assess risk and recommend safety measures. Not everyone responds to toxins in the same way. Factors like age, gender, genetics, and pre-existing health conditions can make some people more or less susceptible to toxic effects. For example, children and the elderly are often more vulnerable. Recognizing individual differences is important for personalized risk assessment and treatment. Sometimes, exposure to more than one toxin can lead to unexpected effects. Synergistic effects occur when two substances together cause more harm than expected, while antagonistic effects happen when one substance reduces the toxicity of another. Understanding these interactions is crucial for evaluating real-world risks where multiple exposures are common. Toxicity testing is a key part of toxicology. Scientists use laboratory tests to determine how harmful a substance is. These tests can involve cells, animals, or computer models. The results help set safety standards and guide regulations. Advances in technology are making testing more accurate and reducing the need for animal experiments. One common measure in toxicology is the LD50, or lethal dose for 50% of test subjects. It helps compare the toxicity of different substances. Other measures include NOAEL, no observed adverse effect level, and LOAEL, lowest observed adverse effect level. These benchmarks guide safety regulations and help protect public health. Risk assessment is the process of evaluating the likelihood and severity of harm from exposure to a toxin. It involves identifying hazards, assessing exposure, and estimating risk. This process helps governments and organizations set safety standards and make decisions about chemical use. Effective risk assessment protects both people and the environment. Regulatory toxicology focuses on setting and enforcing safety standards for chemicals. Agencies like the EPA and FDA use toxicological data to regulate pesticides, drugs, and industrial chemicals. These regulations are designed to protect public health and the environment by limiting exposure to harmful substances. Environmental toxicology studies how chemicals affect the environment, including plants, animals, and ecosystems. It examines pollution, bioaccumulation, and the movement of toxins through food chains. This field is vital for understanding and preventing environmental damage, ensuring a healthier planet for future generations. Occupational toxicology focuses on chemical exposures in the workplace. Workers in industries like manufacturing, agriculture, and healthcare may encounter hazardous substances. This field aims to identify risks, set exposure limits, and develop protective measures to keep workers safe and healthy. Forensic toxicology applies toxicological knowledge to legal cases. It involves analyzing biological samples for drugs, alcohol, or poisons in cases of suspected poisoning, overdose, or crime. Forensic toxicologists play a key role in criminal investigations and court proceedings, helping to determine causes of death or impairment. Clinical toxicology deals with diagnosing and treating poisoning in humans. Medical professionals use toxicological knowledge to identify symptoms, provide antidotes, and manage patient care. This field is essential in emergency medicine and helps save lives in cases of accidental or intentional poisoning. Food toxicology examines the safety of what we eat and drink. It studies natural toxins in foods, food additives, contaminants, and the effects of food processing. Ensuring food safety is a major public health goal, and toxicologists work to identify and minimize risks in the food supply. Pharmaceutical toxicology focuses on the safety of drugs and medicines. Before a new drug is approved, it undergoes extensive toxicological testing to identify potential side effects and safe dosage ranges. This field ensures that medicines are both effective and safe for patients. Ecotoxicology is a branch of environmental toxicology that studies the effects of toxic substances on ecosystems. It looks at how pollutants impact plants, animals, and entire communities. This field is important for understanding the broader consequences of chemical use and for developing strategies to protect biodiversity. Carcinogenicity refers to a substance's ability to cause cancer. Toxicologists study which chemicals are carcinogenic and how they trigger cancer development. Understanding carcinogenicity helps set exposure limits and guides public health policies to reduce cancer risk. Mutagenicity is the ability of a substance to cause genetic mutations, while teratogenicity refers to causing birth defects. Toxicologists test chemicals for these effects to protect future generations. Regulations often require testing for mutagenic and teratogenic potential before approving new chemicals or drugs. Some toxins build up in living organisms over time, a process called bioaccumulation. When these toxins move up the food chain and become more concentrated, it's called biomagnification. These processes can lead to serious health risks for both wildlife and humans, especially with persistent pollutants like mercury or PCBs. There are many common toxic substances we may encounter in daily life. These include household cleaners, pesticides, heavy metals like lead and mercury, and even some plants and animals. Being aware of these substances and how to handle them safely is an important part of toxicology education. Symptoms of poisoning can vary widely depending on the toxin and the amount of exposure. Common symptoms include nausea, vomiting, dizziness, confusion, and difficulty breathing. Severe poisoning can lead to organ failure or death. Recognizing symptoms early is crucial for effective treatment and recovery. If poisoning is suspected, it's important to act quickly. First aid steps include removing the person from exposure, calling emergency services, and providing information about the toxin. Do not induce vomiting unless instructed by a medical professional. Prompt action can save lives and reduce the severity of poisoning. Toxins have specific antidotes that can neutralize their effects. For example, activated charcoal can absorb certain poisons in the digestive tract, while naloxone reverses opioid overdoses. Other treatments focus on supporting vital functions and speeding up excretion. Medical professionals choose the best approach based on the toxin involved. Preventing toxic exposures is always better than treating them. Strategies include proper storage and labeling of chemicals, using protective equipment, and following safety guidelines. Education and awareness are key to reducing the risk of poisoning at home, work, and in the community. Toxicologists are scientists who study the effects of chemicals on living things. They work in many fields, including medicine, industry, government, and research. Their work helps keep people and the environment safe by identifying hazards, setting safety standards, and developing new treatments. Toxicology is a constantly evolving field. New challenges include emerging contaminants like microplastics, nanomaterials, and endocrine disruptors. Advances in technology are also changing how toxicologists study and predict the effects of chemicals. Staying informed about these trends is essential for effective risk management. Ethical considerations are important in toxicology, especially when it comes to animal testing and human safety. Scientists must balance the need for accurate data with the responsibility to minimize harm. Advances in alternative testing methods are helping to address these ethical challenges. Effective communication is vital in toxicology. Scientists must clearly explain risks and safety measures to the public, policymakers, and other professionals. Good communication helps prevent misunderstandings and ensures that safety guidelines are followed. Real-life case studies help illustrate toxicology principles. Famous incidents such as mercury poisoning in Minamata, Japan, or lead contamination in Flint, Michigan, show the importance of proper risk assessment and regulation. Learning from these cases helps prevent similar tragedies in the future. Future of toxicology is bright, with new technologies and approaches improving our ability to detect and prevent harm. Advances in genomics, computational modeling, and alternative testing methods are making toxicology more precise and humane. Continued research and innovation will help us meet new challenges and protect health worldwide. Toxicology isn't just for scientists, it affects everyone. From reading product labels to understanding food safety, basic toxicology knowledge helps us make safer choices. By staying informed and following safety guidelines, we can reduce our risk of exposure to harmful substances in daily life. There are many resources available for learning more about toxicology. Books, online courses, and reputable websites offer valuable information for students and professionals alike. Staying curious and seeking out reliable sources is the best way to deepen your understanding of this important field. Let's review what we've learned. Toxicology is the study of harmful effects of chemicals on living things. Key concepts include dose response, routes of exposure, and individual susceptibility. Toxicologists work in many fields to protect health and the environment. By understanding toxicology, we can make safer choices and contribute to a healthier world. Thank you for joining this introduction to toxicology. We've covered the basics from key principles to real-world applications. Toxicology is a vital science that helps keep us safe in a world full of chemicals. Continue exploring, stay informed, and remember that knowledge is the best defense against toxic risks. Stay safe and keep learning.